Did you know that Earth has more than one moon? It's an intriguing thought, isn't it? When we think of moons, we typically picture a celestial body orbiting a planet, like our own moon. But the definition of a moon can be broader than that. Some scientists argue that any object caught in a planet's gravitational pull, even temporarily, could technically be considered a moon. That's right. Earth might have more than just the one moon we all gaze at on clear nights. These extra moons, however, aren't quite like the one we're familiar with. They're often much smaller, sometimes only a few meters across. These little celestial nomads are often referred to as mini-moons or temporary moons. They're temporary because they don't stick around for long. These mini-moons are usually asteroids that have strayed too close to Earth and get temporarily snagged by our planet's gravity. But unlike our moon, they don't stick around. They might orbit Earth for a few months or even a few years, but eventually they break free and continue on their journey through space. It's a fascinating concept, isn't it? The idea that we've had multiple moons all along, just not in the way we typically think of them. They're not as big or as permanent as our moon, but they're moons nonetheless. So, it appears that we've been living with more than one moon all along. But how does this happen? To understand how Earth can have more than one moon, we need to delve into the realm of celestial mechanics. The gravitational dance between celestial bodies is a fascinating spectacle that underpins the movements of all objects in the universe, including our Earth and its moons. Imagine the solar system as a grand cosmic ballet, with the sun as the prima ballerina and the planets pirouetting around it. Each planet, in turn, has its own entourage of moons and asteroids that twirl around them. This dance is choreographed by the force of gravity, the invisible strings that pull celestial bodies towards one another. Now, let's add a twist to this celestial choreography. Occasionally, an object such as an asteroid or a comet gets close enough to Earth and is captured by our planet's gravitational pull. This object then becomes a temporary moon, or as scientists call it, a mini-moon. These mini-moons can orbit our planet for a few months to a few years before they break free and continue their journey through the cosmos. So how does this relate to the concept of co-orbital objects? Well, co-orbital objects share the same orbit as a planet but aren't moons. Instead, they follow a complex path around the Sun and the Earth, a dance that can last for hundreds or even thousands of years. But here's the catch. These dances are delicate. The gravitational pull from the Sun and other planets can easily disrupt them. That's why these additional moons are often temporary. They may be part of Earth's celestial entourage for a while, but eventually they pirouette away into the cosmos. The universe is a fascinating place full of surprises, and one of those surprises is that our Earth is not as monogamous as we thought. Yes, our planet Earth, it seems, likes to flirt with more than just one moon. And who can blame her? After all, variety is the spice of life, even in the grand dance of the cosmos. Now that we know Earth can have more than one moon, what's the life of these temporary moons like? Let's dive right into it. These temporary moons, also known as mini-moons, have quite an interesting life trajectory. They are usually asteroids that get pulled into Earth's gravitational field as they pass by. Their journey around our planet can be pretty wild and unpredictable, often described as chaotic. This is due to the influence of the gravitational forces of the Earth, our permanent moon, and the Sun, which act together to create a complex dance of attraction and repulsion. The lifespan of these mini-moons is as transient as their path. They typically stay in Earth's orbit for about 9 months to a few years before they continue their journey through the vastness of space. Just like a boomerang, they come, they spin around for a while, and then they go. Now, you might be wondering, if we have these temporary moons, why don't we see them more often? Well, spotting and tracking these mini-moons is no easy task. They are usually small, often no larger than a meter across, making them difficult to detect against the backdrop of the universe. Additionally, their erratic orbits make them even more challenging to track. Nevertheless, the discovery of these temporary moons offers us unique opportunities to explore and understand the cosmic neighborhood around us. They provide us with a close-up view of the asteroids that roam our solar system, offering valuable insights into their composition and origin. These temporary moons come and go, leaving us with our faithful companion, the moon we all know and love. Despite their fleeting presence, these mini-moons remind us of the dynamic and ever-changing nature of our universe, where nothing remains constant and every moment brings something new and unexpected. The discovery of Earth's temporary moons might seem like a mere curiosity, but it has far-reaching implications. These transient cosmic tourists offer us a unique opportunity to learn more about asteroids and the early solar system. They are like time capsules, carrying with them the history of our solar system, untouched and unaltered for billions of years. Studying these temporary moons could also aid in understanding the challenges and potential solutions for future space exploration and colonization. Take Mars, for example. Elon Musk's ambitious plan to colonize the red planet has been met with skepticism due to the numerous challenges, including the planet's lack of a magnetic core to maintain a protective atmosphere. By studying our temporary moons, we could gain valuable insights into how to overcome these obstacles. Then there are the possibilities that come with the moons of other planets. Recent data from NASA's Juno spacecraft suggests that Ganymede, Jupiter's moon, could harbor life. Ganymede is the largest moon in the solar system, and it generates its own magnetic field. This challenges the notion that places like Ganymede are inhospitable to life and warrants further exploration. Now let's consider the future of Earth's moons. With advancements in technology, it might be possible in the future to capture and study these temporary moons up close. This could open up a new era of asteroid mining, providing us with resources that are scarce on Earth. However, let's not forget the role our permanent moon plays in our lives. The gravitational pull of the moon causes tides on Earth and affects our planet's rotation. Over billions of years, this has resulted in longer days. So while the moon might often be taken for granted, its influence on our planet is profound. As we continue to explore the cosmos, who knows what other celestial surprises await us. For now, let's appreciate our solitary moon and its fleeting companions that drop by from time to time.